Hey everyone, and welcome. Today we're going to dive into a project that honestly feels a little bit like magic, but it's the perfect first step into the world of smart technology. We're going to show you how a simple sound can literally command the world around you. So let's get right into it. I mean, just think about it for a second. No more fumbling for a switch in the dark, no more having to get out of your cozy, warm bed, just a simple clap, and boom, you've got light. It might sound like something straight out of science fiction, but this core idea is one of the key building blocks of modern automation, and we're going to break it all down for you right now. All right, so what's the big idea here? Before we get into all the nuts and bolts, let's just make sure we understand the simple yet really powerful concept that makes this whole thing possible. At its heart, a smart clap switch is exactly what it sounds like. It's a system designed to listen for one very specific input from the world, the sharp sound of a clap, and use that sound as a command to turn something on or turn it off. It's a perfect bite-sized lesson in how we can get our electronics to actually listen and respond to us. Now, to make this magic happen, we're going to need a few key players. But instead of me just rattling off a boring list of electronic parts, let's think of them as a team, A crew where every single member has a super specific and crucial job to do. So to make this really easy to remember, we're going to use this simple analogy. We have the ears, which, you guessed it, listen for the command. We have the brain, which decides what to do with that command. And finally, we have the muscle, which does the heavy lifting and carries out the action. Simple, right? Let's meet them. So on one side, we've got the ears. That's our sound sensor. Its one and only job is to listen for that clap. On the other side, we have the brain, the Arduino Uno. As soon as the ears hear the command, they pass that info along to the brain, which processes it and decides what to do next. Two totally separate parts, but they work together perfectly. So you can think of the Arduino, our brain, as the manager of this whole operation. It's constantly listening, just monitoring the signal coming from the sound sensor. The moment that signal says, "Hey, clap detected," the brain kicks in and follows its programmed rules. It checks if the light is on or off, and it just flips it. If it's off, turn it on. If it's on, turn it off. Now, let's take a closer look at how the ears actually work, because they're pretty smart. The sound sensor doesn't just hear everything. It has a microphone that turns sound into an electrical signal, but the really clever part is that it can compare that signal to a level that you set. This means you can actually adjust its sensitivity, basically telling it to only react to a loud, sharp clap, while totally ignoring stuff like background music or a conversation. Okay, wait a minute. So we have a problem here. The Arduino brain, it runs on very, very low voltage. It's a thinker, not a power lifter. So how in the world can it possibly control a high-power device like a regular light bulb without just frying itself? Well, it needs some help. It needs muscle. And the solution is to bring in the muscle, the relay module. The best way to think of a relay is as an electrically controlled switch. The Arduino sends a tiny, safe, low-power signal to the relay, and that little signal is just enough to make the relay flip a much bigger, high-power switch inside of it. It's the perfect bridge between the tiny world of microcontrollers and the high-power world of our household appliances. So, we've met the team, we've got the ears, the brain, and the muscle. Now let's see exactly how they all work together in a perfectly timed sequence. A chain of command that turns a simple sound into a real-world action. This whole thing might seem complex from the outside, but it's really just a very, very fast step-by-step chain reaction. One thing triggers the next, which triggers the next, and it all happens in a fraction of a second. Let's walk through it. First up, here. The sound sensor picks up a clap that's louder than any other noise in the room. Second, convert. The sensor immediately turns that sound into a simple electrical message, basically a "yes, I heard it" signal, and zips it over to the brain. Third, decide. The Arduino sees this signal and makes its decision. Time to flip the light's current state. Fourth, command. The brain sends its own little low-power signal out to the relay. And finally, number 5, act. The relay gets the command and closes its big internal switch, completing the circuit, and the light turns on. It all happens in an instant. So you might be thinking, okay, that's a neat trick, but why does a simple project like this actually matter? Well, let's zoom out for a second and look at the bigger picture. Because the principles we're using here, they are absolutely everywhere. This is so much more than just a fun weekend project. The core concept here, using a sensor to gather input, a microcontroller to process that input, and then an actuator to create an output, that is the absolute foundation of almost all modern automation, from complex robotics all the way to our smart homes. And you see these principles in so many real-world applications. Of course, there's smart lighting systems and home automation, but really importantly, there's also assistive technology that can give people with limited mobility so much more control over their own environment. It's also a fantastic learning tool for things like educational robotics and other noise-activated systems. And this quote just sums it all up perfectly. By taking something as simple as a sound and turning it into a control signal, this project beautifully captures the essence of what embedded systems and automation are all about, making our world more responsive and more intelligent. So now you understand the fundamental building blocks of automation. You need a sensor, a brain, and a muscle. And once you really grasp that simple pattern, the possibilities are just endless, which leaves us with only one question left to ask. What would you automate?